Good morning and happy Monday. I apologize for not being at school this morning. I have a doctor's appointment, so I'm not sick. I had a doctor's appointment this morning. I'll be back this afternoon if you want to come say hi to me this afternoon, and I'll be back to school tomorrow. Right now, you should have your note sheet in front of you. If not, if the teacher could please pause the video and then pass out the note sheet, that'd be great. Okay. As soon as you get that note sheet, you should be starting on the warm-up. Again, if we could pause the video maybe for 3 to 4 minutes to let everyone try to get this warm-up complete, and then press play in about 3 to 4 minutes. So if you can go ahead and please pause the video, that'd be great. All right. So this warm-up, we are approximating the best fitting line for the data. First thing you should do is try to draw a line through the middle of all those points. All right, there's my line. Okay, now I'm going to look for 2 points on that line. Remember, on the line, not on, or not a specific point that's already graphed, but a point on my line. I see a point here that I'd like to use, and I'm actually going to use that point right there. Okay? Once you create your line, once you find 2 points on your line, let's go ahead and mark those 2 points. This first one on the top right is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3, 4, 5. So my one point is at 10, 5. My other point is at 1, 2, 3, 4, down 1. So 4, negative 1. Next, we have to find the slope using the equation y2 minus y1 over x2 minus x1. And when I find that slope, negative 1 minus 5 is negative 6 over 4 minus 10, which is negative 6. So my slope is actually at 1. Now my line might not be the best. It might not be the most accurate. But your slope should be somewhere in that ballpark around 1. Next, I'm going to create my equation. 1x plus b, because I found m, I'm just going to replace m with 1. Now I'm going to pick one of my 2 points to put into x and y. I'm going to choose 10, 5. So 5 is equal to 1 times 10, not 10 times 1, 1 times 10, plus b. Now I'm going to solve for b. I get 5 equals 10 plus b. I'm going to subtract 10 from both sides, and I get negative 5 is equal to b. So my equation, and this equation should be similar to yours, is y equals 1x minus 5. Okay? That's the warm-up. Let's move on to our notes for today. This is 2.6. This is the last lesson in Chapter 2. Okay. Linear inequality. Let's start with the word linear. And a word in linear is line. We've been working with lines throughout Chapter 2. And we've been using this equation, y equals mx plus b. Linear inequality is very similar to that. But instead of an equal sign, it's a greater than, less than, greater than or equal to, or less than or equal to sign. Okay, so the inequality can be different. And what I mean by that is right where that's greater than, it could be less than, it could be greater than or equal to, or it could be less than or equal to. It could be one of those four signs in place of the equal sign. Next is solution. I have to find that. Okay. Solution is an ordered pair. Meaning just x, y, right? A point, a coordinate. That gives a true statement. Okay, so it's just an ordered pair x and y, that's a point, x, y. That gives you a true statement when you plug x and y in. Okay. Graphing. Again, I always like examples over writing down definitions. However, this is very important to write down. Graph with greater than or less than, we need to have a dashed line. Okay, so if we have a greater than or less than symbol, we have a dashed line. Think about back in chapter 1, when we had greater than or less than, and we were graphing those, we had an open circle because it was not included. Right? The answer was not included. Same kind of concept here. It's not a solid line because it's not included, right? It's only greater than or less than. With greater than or equal to, or less than or equal to, that's when it is included. We're going to have a solid line. Okay, and we're actually going to do a little bit of shading today. Shading, like coloring, or however you want to phrase it. When y is greater than, or y is greater than or equal to, we shade above our line. And when y is less than or equal to, we shade below our line. Okay. All right. Moving on. The next page. What we're doing is we're checking whether the given ordered pairs are solutions of the inequality. Remember, all of these points are just x, y coordinates. X, y coordinates. What we're doing is just plugging those into x and y. So that first one, y is 2, is less than negative 9 times negative 2. Right? All we did was plug in the 2 coordinates plus 7. All I did was plug in x and y into those two spots. Next, we're going to solve. So 2 is less than negative 9 times negative 2 is a positive 18 plus 7. Next, we just simplify. What's 18 plus 7? That's 26. No, 25. Wow. Ooh. Rough math. Sorry. Monday morning. Okay. Then we ask ourselves, is 2 less than 25? The answer is yes. So this checks off. That's good. And we're just going to do that for the next 3 ordered pairs. Plug in x, plug in y. Negative 8 is less than negative 9 times 3 plus 7. That's just this one right here. Do some math. Negative 8 is less than negative 9 times 3 is negative 27 plus 7. We get negative 8 is less than negative 20. Is this true? Is negative 8 less than negative 20? The answer is no. Negative 8 is greater than negative 20. It's a bigger number. Okay, next, 0, 9, we're just going to plug in those. So 9 in for y. Negative 9 times 0 plus 7. I know negative 9 times 0 is just 0. So is 9 less than 7? The answer is no. Right? So that one won't work. And lastly, 7, 0. We're going to plug in 7, 0. And we get 7 is less than 7. Is this true? The answer is no. All we do is plug in those values. All right. Moving on to the next one. This one is a little different. If you look at our equation, 2y is greater than or equal to 7. We don't have an x variable. So when we plug in our point, the first one, x comma y, if we don't have an x variable, we're not going to do anything with our x coordinate. We're not going to do anything with the 1. The other thing we care about is this negative 6. And we're going to put that into y. Oh, that's ugly. I'll rewrite that. My apologies. 2 times negative 6 is greater than or equal to 7. What's 2 times negative 6? It's negative 12. Is negative 12 greater than or equal to 7? The answer is no. Negative 12 is not greater than or equal to 7. Next, we're going to try 0, 4. This is x comma y. All we care about is the y. 2 times 4 is 8. Is that greater than or equal to 7? Yes. 8 is bigger than 7. Our last one, x comma y. We're going to plug in 3.5. If you need to use a calculator, go for it. 2 times 3.5 is 7. Is 7 greater than or equal to 7? Yes, it is equal to 7, right? So that works. All right, that is checking for a solution. Next, we're going to be graphing. We're going to be graphing. Both of these equations are going to be graphed on the same graph. We're going to start with this equation here, or this inequality, sorry. X is less than or equal to 6. I'm going to rewrite this in something we kind of remember. X equals 6. That was a line right on the x-axis, right at 6. Everyone should have a point right at 6 on the x-axis. And then ask yourself, is this a horizontal line or vertical line? If it's x equals a number, it is a vertical line. So we're going to have a line going straight up and down through that point. Look at our sign in the middle. Okay, that's a less than or equal to sign. When we had an equal to sign, we have a solid line. So we have to draw a solid line right through 6. Now, if you go back to the first page, and we took notes, and we took some definitions, we have to think about shading. Okay, now x is less than or equal to 6. Think about which side of the line is less than 6. Is it on the right side or left side of that line? If we're thinking numbers, right, this is the less than 6 is everything on the left side. So when we're shading these, this is what I mean by shading. Everything on the left side is going to get shaded in. Now let's focus on this one. Y is greater than 1. I'll rewrite this up top. Because y is equal to 1. We go back to that because that looks more familiar to us. Y equals 1. That was on our y-axis. We put a point right at 1. And think, is this a horizontal or vertical line? Well, if x equals 6 is vertical, y equals 1 is going to be horizontal. But we have to think about that middle inequality sign. Greater than. It is not greater than or equal to, it's just greater than. So we actually have to have a dashed line through our point. Now we have to shade. If it's greater than 1, think about which side of that line is greater than 1. Is it above that line or below that line? Greater than everything above. So that's what we have to do to shade our graphs. That's how we graph our solutions. Moving on to the next one. Okay, next inequality to graph. I'm going to write this equation now, y equals mx plus b, because that's what we're familiar with. When we did y equals mx plus b last week, m is our slope, b is our y-intercept. This inequality is not in that mx plus b form. I'm going to rewrite this. All I did was switch the negative x and the minus 4. Okay, this is more familiar to us. Now, we can look at what's our b. Our b is negative 4, so put a point right at negative 4 on our y-axis. 1, 2, 3, 4. Put a point here. And then, what's our slope? Our slope is m, what's in front of x. And there's a negative sign there. It's really just negative 1. So we have to go down 1 and over 1. So down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Okay, there's our line. Now we have to look at our inequality. Our inequality is just greater than. It's not greater than or equal to. So we actually have to have a dashed line through those points. Okay, now when it comes to shading, y is greater than. Think about which side of that line we have to shade. If it's greater than, we go to the bigger numbers, so everything above our line. Y is greater than, so I have to go above the line. Next one. Again, this is not in mx plus b form. I'm going to rewrite this. I'm going to add 11 to both sides. So I get y is less than or equal to 3x plus 11. And now I'm going to look at what's my b, and that's 11. So we're going to put a point right at 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's like right here. and our slope is 3. Up 3 over 1. Now I can't go up anymore. I don't have any more room on my graph. So I'm actually going to go down 3 until the left 1. 1, 2, 3, left 1. It's the same thing. Still that positive slope. Just now we actually have nice points on our graph. Okay, now think our inequality. It's less than or equal to that's a really bad line. I'm sorry. Okay, now we have to think less than or equal to. Y is less than or equal to that. If you think about our line, okay, we have to shade below that line. Because it's less than, below the line is everything down here. Okay, moving on here. The next one. Try this. Try graphing. If you could pause the video for 2 minutes, that'd be great. Give them some time to try it. Thank you. Okay, when you get back, look at what's your B. It's at -5. I need to point at -5. 1, 2, 3, 4, 5. Your slope is 3 over 4, so we have to go up 3 to the right 4. 1, 2, 3, 1, 2, 3, 4. I just go always from my y-intercept up 3 over 4, or whatever my slope would be. 1, 2, 3, 1, 2, 3, 4. Now I have to look, is it a dashed line or solid line? It's a dashed line because it's not equal to, it's just less than. So dashed line. And now y is less than that, so we have to shade below the line. Below the line. Okay? So it's just graphing. The only difference is we have a dashed line or solid line, and then we have to shade above or below the line. Last one. Let's get this in y mx plus b form. Y is less than or equal to mx plus b form here. I'm going to rewrite this, or I'm going to manipulate this equation, or this inequality. I'm going to subtract 9x from both sides. I get negative 9y is greater than negative 9x minus 36. Now I have to get y by itself. And to do that, I have to divide by negative 9 on everything. So last, I get y is greater than... almost made a major mistake here. When we divide by a negative, or multiply by a negative, what happens to our inequality? The same rule still applies. The sign flips. Now, I almost made a major mistake there. I'm glad I caught myself. On the right side, negative 9 divided by negative 9, that's just 1. So we're just going to have x. And negative 36 divided by negative 9 is a positive 4. So here is my inequality. We have to graph that. Start with your b. It's at 4. So positive 4, put up 1. And our slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. Dash line or solid line. A dash line. And then which way are we going to shade? If y is less than that, we're going to shade above or below. We're going to shade below. Okay? Next is homework. Homework is at 2.6. Numbers 1, 2, and then 7 through 21. 1, 2, and then 7 through 21. So if you just look at your notes, I'm going to pull up the homework on here. Okay, I'll make sure this is published by the time class gets going. And then I'll zoom in a little bit here. So for numbers 1 and 2, you have to plug in x and y coordinates, see if the solution is true, and then 7 through 21, you have to graph. There is graph paper on the table in front if you need it. And then take the rest of the hour to work on homework. Thanks. You can pause this video too right now to keep this homework up.